And here I am. Good morning, everyone. Can you see me? Is everyone? I think yes. So, just in case, if you want to know, uh, um, it is 10 minutes that I was. Hey, good morning. Uh, if you want to know, it is 10 minutes that I was talking to the camera, and I thought that I have removed that screen that says live in 10 minutes. So I was already talking to the camera, and I didn't realize that no one could hear me because I wasn't really streaming anything. There were just a screen that says live in 10 minutes, but I was already talking to the camera, pretending, "Hey guys, are you there? I'm ready. I'm pumped," and so on and so on. Imagine. It's fantastic. Anyway, so first of all, I would like to I would like to tell you something slightly technical. There is this. If you look at the video description of this particular lesson, you may find a link that says, let's see if I can open here, down here. You can see this, that is join my Discord channel. Basically, uh, what is Discord? Discord is a free. This is more important. It is a free voice chat. There is not like a one-to-one chat. It is like a chat room. So uh, if you want to try, it is also a free app that you can download on your phone, iOS, Android, or on the laptop, Windows, whatever. I mean, this is an experiment that I would like to do that basically allow you to talk in real time, like we are in a real room. So if you don't mind, and if you want to check if you can install it and run it, then maybe it is something that will start working at fully after Easter break. But if you don't mind, try this so that we can basically talk in real time while the video is running. So the app is called Discord. It's not sponsored also because it's a free app. And if you want to give it a try, I mean, it's not, it is an experiment. So basically, what I will do is in my headphones, I will hear your voices, and probably that could be a faster way to interact while we are making these live streams. Okay? I'm also checking which is best and faster way to share your screen with me in real time. So I just need to check if best solution is, I don't know, Skype or Google Chrome remote desktop. There are plenty of options, and this would be also my homework during the break. Okay? And last but not least, if you are ready, I would like, before opening some of your midterm exams to review them and to show you, I mean, how I have done my Lego bricks. What I would like to do is I would like to explain what you may do during the Easter break in order to start your Inventor final project. Okay? So, let me know if I'm just watching the chat. Let me know if you are ready to know Inventor final instructions. Just give me a sign so that I will open basically the whiteboard and I will write instructions so that you will keep them. I mean, you can review them in this video. Let me know. Woo-hoo-hoo. Someone, wait. Someone joined my Discord chat. So let me see if it works first. Let me see. So that I use the Discord. Let me see. Okay. I have no idea how it works, by the way. It's the first time that I'm trying. So I hope it works. View my channel. Voice chat. Okay. If you are on the Discord, can you hear my voice or not? Because I have no idea how it works. I mean, I can see that I am speaking and the microphone says something inside the Discord. Then just let me know if you can hear my voice as well. I mean, just to check if it is something useful or just a waste of time. Okay. Let me also close Discord from here. Perfect. Okay. Voice channel FTA. Okay. Okay. I have no idea how it works, honestly. Anyway, so let's explain what you have to do during this break in order to being able to make a final project in Inventor. That will be this. Your goal is something very important. So let me delete this one. We have Teodoro says, I can hear you, but can you hear me? Unfortunately, no. Okay, Theodoros, you should use headphones because I can hear you, and I mean, I can hear that you are hearing my voice, so I hear my voice again on my headphones. But I can't hear your voice. Anyway, let's forget Discord for a second. Let's go to Inventor channel. Then we will practice this, and we will do this during the during the break. So, what you have to do as Inventor final project. Final project. Will be this. All of you may have a slightly different interest in using in industrial design. What it means. There are maybe students who are more into furniture design, product design, and design of electronic things and stuff like that. So, which is my goal? My goal will be you need to create a mood board and in this mood board you have to describe which is an object of industrial design that you are interested in designing. What it means? Let's say someone wants to make a armchair, someone wants to make a bookshelf, or someone wants to design a lamp. I mean, whatever is the object, a boat, a vehicle, whatever. So you have to describe the object that you would like to develop in order to use it as like object for your final portfolio. So when you will go to a client, to a potential client, and you want to show your portfolio, instead of having like all same project like school projects, so this will be something a little bit more personal, something that comes from your particular design interest. And you have to start so doing explain me which kind of object you would like to design by using whatever method you prefer. What it means, you can download existing pictures, you can start designing your own personal object by making sketches, by making very rough 3D models. The only thing that this object needs to have in order to be useful and usable in the Inventor final project is that this object must be not one monolithic object like just one shell, I mean one solid, but it has to be an object that at least is made by three, no, at least it has to be made at least by three parts. So it is an object that it is like a base, a handle, and a cover. Something that is not just one simple 3D model like I want to make a statue. I mean, so that is just one single part. This is not allowed. Minimum request is that the object that you design is something that is made in three separate parts. This is the minimum. Can be more, but not less. For example, last semester I discovered that all my Inventor students, they have all made lamps. And what is interesting is that they were also able to make their prototypes of their parts by 3D printing some pieces. So, because I haven't forgot that this is also a class about 3D printing, I would like to make a very interesting experiment. That is, you have to design your piece, and after the break we will make a specific lesson about 3D printing, and I will explain things that you have to do, which softwares you have to do, and what I will try to do is, after the break, when you design certain pieces, I will try to go to the school, and I will 3D print some of your small parts, so that maybe during the class then I can show you, I can rotate them into the webcam, I can show you which are criticism, I can show you which are main problems that the 3D printing process does, and so on and so on. So we will try, I will try to 3D print some of your objects, your print some of your objects. And this is my goal. Okay, so the last but not least, to have all complete information, the mood board that you have to create, and this is what you have to do for these 2 weeks, must be in PDF format, and it has to be at least made by 3 pages. I will say at least 3 pages A4 containing all informations needed to understand which project you want to create. Okay? So sketches, informations, description of which material, description of the function, if it is an electronic device or not, if it is. Okay? Tell me if this was clear enough or not. Let me see. In the meantime, I'm checking again if this is working. Okay, we have one yes, clear, perfect. If you want a suggestion, then for your object, don't go too crazy. Try to select something small in terms of dimensions and in terms of number of parts. For example, let's see if I can, I have this small lamp in here. I don't know if you can see it. I think so. But this is a very small lamp that I use for photography in general. But this is a perfect example of an object that can be really made in Inventor. I don't know. Tell me if you can see it clearly. And why this is something that is simple to be made. For example, because it has a few screws, so you can like design this particular knob, then this is another separate piece, this is one block, and here there is just an additional knob. And then light itself, it's something that comes basically in three parts. So you see it as final object, but in reality it is made in three parts. There is like a single screen, there is a light diffuser, and then this plastic box, in reality, I mean, this will be very hard to be seen into the camera, but this is in reality something that is divided in two. So there are two plastic shells that are then attached together with four screws that are here. And inside there is an LED panel. Of course, you have not to design you have not to design it the electronic or stuff like this. This not, but this is a clear example of an object that can be easily developed in Inventor. Okay. If I was a real YouTuber, then I should say like, and you find an affiliate link to buy this one into the description down below, but I'm not, so I'm not a serious YouTuber, so I haven't created an affiliate link for that lamp. Okay, someone says also, Sophia says that she can hear me on the Discord, but I would like to see if I can hear you as well. And I don't know how to enable your voices. This is what bothers me the most, is not understanding how an app works. So I don't know if I have to add all of you as a friends. I have no idea. And I'm adding everyone. And I would really like to understand how this thing works, because it could be interesting. Okay. So I mean I can see that when I whoa, yes! This is great. I can hear one of you. But again, I can hear my voice back. And so when you use this kind of app, try to avoid audio feedback. So or you mute your laptop or you use headphones and stuff like that. Okay? That is particularly weird, but it's okay. I mean, it's just to have. Exactly. But this is why it does work at least. So it's a step forward. It's okay. So now let's move on. Let's move on to Inventor. And ciao. Okay. Let's go back to Inventor and let's review some of your files that I have downloaded. Of course, I've selected some of them, not them all. I want to open them to discuss. Now I remember why I downloaded this one. Look, this file is a file that is made with an Inventor file, Inventor that is newer than mine. I use Inventor 2019. This has been made with Inventor 2020, and I wanted to show you this resource. This is why I've downloaded this part, because look, if you have this kind of problems, you need to remember that you are, by downloading original softwares from Autodesk, you are students that can access more Autodesk resources. For example, one interesting website that you can use and for free also is this one. Then I will also copy this link into the chat. And basically what you have to do is you have to log in with same user and passwords that you use while you are basically logging into the education portal. And why this is an interesting website, and I will copy the link in here. I will paste the link here. That is viewer.autodesk.com. Simply because if you receive a file and you are maybe not even at home, you have not the chance to check a file, or you want to check it from the mobile, you have received it as attachment and so on and so on. What you have to do is you log in to viewer.autodesk.com. You click upload a file, and you simply look, drag and drop the file that you are not able to see. It takes a second. I mean, it processes the file. We are almost there. And basically, even if I have not the software with me, or if, let's say, especially if you are like working with Mac and Windows and you don't want to switch from a platform to another, boom. But in here, you have also the chance to check whatever Autodesk file format for free. I mean, so this is also interesting because some students asking me, can I keep like 2020 and so on and so on? And I say yes, because it is always possible to open files, even if you have not the app. And you have some interesting tools, like you can orbit, pan, zoom, but you can also measure. So I do this not only to open files, but I can also check if they are correct or not. You can also make, press escape, you can make sections somehow, that I forgot how to do it. Exactly here. Then I can rotate, for example, like this. Perfect. Then I can use like the Y plane. I can rotate it. I can exactly slide the section plane to see how this 3D model has been done, and so on and so on. So this is a useful resource. If this was an assembly, for example, you can explode it, so you can split all parts. This unfortunately is just one part, so you can do it. You can also mark up, so you can start adding notes and then save these notes so that you can use it as a reviewing tool even if you have not apps with you. So you can add cloud things like check it here, you can put arrows and so on and so on. Okay, and this is this simple free tool that you have. You have also, when you log here, you have more web apps that you need to know, like you have Beam Team, so if you are running Revit projects, you can you can share things with other people. But what is more important is that you have also Autodesk, AutoCAD 360 and Fusion 360 that basically are Autocad online, and Fusion 360 is simply a more or less a web version of Inventor. So again, if you have not your laptop, if you are running whatever computer, also Windows, Mac, and so on and so on. These are web apps, and you can also use them. For example, now I don't need it, but with the viewer, I'm able only to see the file. But if I use AutoCAD 360 or Fusion 360, I am able not only to view, but I can open this file, adjust it, and maybe I can save it with another format, and I can export it, and I can use this part for the software that I have. Okay, so this is extremely important because web apps are, just by having a decent internet connection, they allow you to work wirelessly, no matter where you are, no matter which software you need. Autodesk related, of course. Okay? So this was example number 1, just to show you a new interesting resource that all of you can access. And remember, those are 100% for free due to the fact that you are using student softwares. And this is first. You see? Okay. Then let's open another file. Let's see this one. This is the same. This one. And this, no, this is fine. So I want to open another one, but I don't know where I saved it. Let me see if I can easily find it. No, this is not here. So I will download it again. Okay, because this was pretty good, and I wanted just to check which steps have been made here. So this is an extrusion that goes to. This is another extrusion that is by making these parts in here. This is another extrusion. These are other extrusions. This is a sketch that this is this. Okay, this is interesting. Look, because to see how this object has been made. I mean, those are a copy of your files. I'm not ruining all of your original files. But I want to show you this. So if I check how the file is made, I will discover that this is the cap that has been extruded 1 millimeter. Okay? While, and I can delete it now, while this is a very complex extrusion that has been made by drawing this entire sketch with dimensions, okay? And then it has been pulled up. Where is here the downside? I mean, why maybe this is quite correct, but why this becomes something a little bit complex to be managed? If I want to make another Lego block, this is the one that, let me open the pen also, big pen. This is a brick that is called, this is called 2x4 brick. In Lego dictionary, this has a very precise meaning that says it is an object that has 8 cylinders. There are 2 on the short side, 4 on the long side. It is called brick. So what it means is that the height of this will be a multiple factor of 3 elements. And into the Lego there are bricks and there are plates. Plates is one module. If you put 3 plates on top of each other, you obtain a brick. So there is something like a modular aspect of Lego blocks. And also they change dimensions. So there is like 2x2, 2x4, 2x3, 1x4, 1x3, 1x6, and so on and so on. So where is here the only small negative aspect? Negative aspect is that if I want to change this and I want to make it shorter or longer, this sketch, there is one sketch that, look, contains all these details, is simply a sketch that will take forever in order to be modified, because if I cut it, let's say here, and I want to make only this part, I have to cut it, move it, delete this small part, delete this small part, and so on and so on. Let me see another interesting thing. That is, let me show you, not because it is better, but because it is a little bit more reliable. Yes, okay. So let's say no. Let me show you how I did one of these. That is this one. Look. Let me open also the chat. I would like to see the chat next to me so that if you have message, I will see them in real time. Here. Okay. So let me show you my Lego block, just because it can be interesting to see other ways to do same things. First of all, I have added chamfer simply because I have a lot of Legos and I know that bricks are sharp but not that sharp. So this is, I mean, nothing really important. So we can remove this. Then, let's see. Last thing that I have done is I have made an extrusion. So let's start from last step. And what is this extrusion? These extrusion are these small elements in here. So I haven't created this into the same sketch of the base, simply because if I want to make another block, they are independent from main dimension, and if I double click and I open the sketch, you will also see how the sketch is made. That is particularly interesting. That is this. I have technically made one of these rectangle only. So I have made one rectangle. Then I have applied dimensions to this rectangle so that I fix the side, that is this one and this one, and this cannot be modified. And you can see that my sketch is blue, while previous sketch was green. This is extremely important because if the sketch is green, it means that if you move by mistake a part, you can still deform the object, while when the sketch is blue, you can't. And then look how these other rectangles are made. In reality, this is my starting rectangle, this one. And you can notice that it has a billions of constraints in here. And why this is happening? Simply because in reality I have made this rectangle, then starting from the corner I have made I have made a line that is 45 degrees angled. Okay? And then what I have done is, instead of drawing manually this rectangle here, I have used mirror to make this one. So this one, in reality, is an object that you can see is created by using these axes as a mirror, and it is a perfect copy of this one. Then I have selected both. I have selected these two rectangles, and again I have drawn this axis, used mirror, boom, and I obtain lower rectangles. Then select only these two make this mirror and I create this one. Then I've selected them all. I have drawn middle axis and I have mirrored all these other parts. So technically I have drawn one thing only, and then I have just repeated mirror, 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 boom. In a second I have all these pieces. Why this? Simply because if I need to change dimensions, modify something and so on and so on, look, I can just move and I can't because now this is also stick it here. Let's pretend that this constraint is not here. But if I move one mirroring axis, you will see that I am able to quickly adjust all my attached objects. Okay? So I create parametric relationships between all my pieces. So, and this is just for this lower part. Let's see what I've done here. This is the same as your classmate. This I've just made an extrusion, nothing fancy. And let's see here. Again, another extrusion, but I want to show you how I did it. Because again, what I do is I create a lot of construction lines. So instead of drawing things randomly into the plane, I create lines that are connected to my previous geometry, and then I attach sketches to them. I'm explaining now, then I will make a real example, but just to explain what I did. And then this is the fun part. That is how I've made main brick. There is something that is unbelievable, because if you remember in the example that I have opened from a student, you had lower part, upper cap, and those 8 cylinders extruded up. And if you see instead, I have a lot less steps, but the result is basically the same. So I want to show you from scratch what I've done, because I think it is particularly interesting in order to understand just different ways to use Inventor. And see this. What I have really done is this. Starting from upper plane, I started from a box. Now, I don't remember dimensions, but wait, no, give me a second. But I have dimensions here. Okay, so let's use also real dimensions. So what I started in this way. Look, I've made a box by using box tool, and I have used dimensions, so there are 13.8, tab to go to the second value, and this is 15.8. Then box asks me for the height, and the height is 9.6. Boom! And this is first. Okay? Now I have to place my 8 cylinders on top of this face. Okay? So what I can do is I can just draw them, but let me show you what it means creating parametric relationships in between elements. So what I do is this. I select the face where I want to draw and I click Sketch. Then I know that I have to make 8 circles in here, but not just 8 circles somewhere. There is a very specific distance in between. So what I do in reality is first this. Look, I create axes. Okay. And these axes will create the center position of my circles. So I can use also mirror, but it's okay. Let's make it simple. Where is the problem? The problem is that these kind of shapes cannot be extruded because they are open shapes. So what I have to do is, they are construction lines, and the construction is a tool, a button that you find here. This one. If I set my lines as constructions, they won't be used from features like extrude or revolve or loft. So what I have to do is simply I select them once that I draw them, and I click this tiny button that is construction lines, and they will be barely visible. They become dashed, okay, but not as center line that is useful for mirror. They are construction, they are thinner. So what I do is, after this simple step, I read from the drawing, I read dimensions, and I discover that the distance between all these construction lines is 8 millimeters. So what I do is I click one line with dimension and another line. This dimension is called D4. I type 8, that is my value, and I click OK. Once that I have done this, I make this other dimension, but I don't write 8. I type D4, so that if I change my mind, instead of 8, they will change in a parametric way. So I call it D4. I measure this, and this is D4. I do the same in this direction, and I call it D4. Okay? I have almost done. I need to center these lines properly into my final drawing, and I can read that from here to here the distance is 3.9. 3.9. And I can also read that this dimension is called D8. So I move this 3.9, and I do the same by measuring this dimension here. It has to be again 3.9, so I don't write 3.9, but I write D8. Boom! In this way, my axes are perfectly placed into my object. So what remains to do is, now I make one circle, one only, that starts from the intersection of two of these construction lines. I can read the diameter, that is 4.8. So I will type 4.8. Perfect. And now I don't draw all other circles. What I do instead is this. I press escape. I select this circle. I use this simple tool that is called copy. And copy works like this. I select it. Then and stay there. I click base point. My base point is the center. And from there, I play. I don't know why my mouse is becoming crazy. Wait a second, because can you see me? Can you hear me? Everything is working. Because for a second I thought that Inventor was crashing. So let me know if you can see me, hear me, and everything works. Give me just a feedback that you are able to hear me. Yes, perfect. Sorry. For a second, Inventor started flickering, so Inventor started flickering and I started freaking out instead. So I was saying, I select these, click copy, from the base point that is my center, and I simply put all other circles. You can also be, look, let's say if I'm not precise, and by mistake I do this. This is not the end of the world. Look, I will do this on purpose. Just to show you that you can fix these in a better way. That is, first of all, I have made copies of all my objects. And this is perfect so that they are the same. If I've made this kind of tiny mistakes and I'm not sure that the center is perfectly attached to that intersection, this is not the end of the world, because with the menu that is called Constraint, you can use Coincident Constraint. So I click Coincident, I select the center of the circle and then this intersection, and then the center of the circle and this intersection. So now you can see the difference, that is, my circle has become blue. It's not more green, because, like the first one, because in this way my center is sticked to vertical and to horizontal line. And this is perfect, because if one day I realize that I need to move this line, wherever I move that line, my circle will always follow it. So let me quickly fix all these other circles by using coincident to a line and then again click coincident to another line, so that I will be 100% sure that the center of all these circles is snapped. This was already there, but just in case. but okay. And I click finish. Then check this. I read that these objects must be extruded. Okay. I can read that the extrusion is 1.8, and I will type 1.8. Okay. And I have this particular object. Look, this is something, and you can see that I've made just 2 extrusions. Okay? But if we open our original, that should be here, the PDF 2x4 brick, we can see that this object is hollow inside. This is the original PDF. We can see that this is hollow, and it is particularly complex because look at the shape inside. It has to be something like this, so something that follows outer shell, and it looks like this is a complex part, while this is super easy. So check this out. What I do is simply I select this face. That is where in reality there is the hole to mount other bricks. I use the tool that is called shell, and I type, I think it was 1.2, and I type thickness that I want. I click OK. Ready for this? And in 1 second, you have the brick that is also hollow inside, and it has exactly those small holes inside these cylinders. Till here? I know that some of you can say that it's not 1.2 everywhere, but I was prepared. I was prepared because basically, let's see. If I remember, this basically is 1.2 in vertical areas, and let's see if I can make it in wireframe. Exactly. So your classmate says it's not 1.2 everywhere. In reality, basically, it is. Let me sketch. It is 1.2 only here. This one is 1 millimeter. It is not 1.2. It is 1 millimeter. Is it true? Let me know. Is it true or not? The answer should be yes. And do you want me to fix also this or not? Alls are 1.1. Where this is written. One point one. I don't trust you. I don't trust absolutely what you're saying, because from my drawing, if it is, no. Yes, I have this one. So I have someone says 4.8, 2.6. That is 2.2. You want to challenge me or whatever? I mean, because I will win in any case. So, so if you want to make it, to make all of these, it's not a problem. So someone says that this from here to here should be 1.2, and from here to here this should be 1.1. That is fine. So let's see other things that you can do. There are these. You can, and I will go back to my normal visual style. So what we can do is, if we have this kind of different sizes, we can start by giving a overall shell, and if we want, we can use the one that is the one that is minimum thickness. So I will use 1. In this way, everything will be 1 millimeter thick, while in here we need to make something a little bit thick, and here something a little bit thick as well. So if we want to do this, then we can select this face, and look, I won't draw anything new, but I will simply do this. I select this face, I make a sketch, and I already have all these circles, and I don't need to draw them again, absolutely not. So what I will do is, after selecting this face in here, what I do is I create a copy of all these circles by clicking Project Geometry. So I click this edge, you will see these yellow circles appearing, simply because in reality those yellow circles are circles that I'm not drawing. What I'm doing instead is I am simply creating them from original edges. Why this? Simply because in this way these original edges are always depending from original 8 cylinders that I have created, and if I move one of my cylinder, I will also move inner circle. So what I will do then is, now they, just to check, if I measure them, they are diameter 2.8, but your picky classmate said that they must be 2.6. There is not a problem. So in my sketch, I will use offset. I select the object and I type should be 0. It has to be, wait a second, I need my calc. So they are 2.8. They must become 2.6 divided, that's to be 0.1. So the offset must be 0.1. Perfect. And I will repeat this process. 0.1, 0.1, 0.1, and 0.1. Look. 0.1 and 0.1. Perfect! And I can finish the sketch. Then I will click Extrude. I select this space to be extruded. Okay? Of course, direction is wrong. But I want to show you that I won't type any direction. So what I will do when I want to extrude is that this extrusion must go from the plane that I'm working on till this face here. So instead of using distance, I will click the option 2 and I will select this inner face. So all my extrusion will reach inner face of my hole. Okay? So now I have fixed inner holes. I have fixed these. One last thing that remains is I need to make these walls. Now they are 1 millimeter thick, but in reality this must become 1.2 millimeters thick. Is it true? Yes. So let's do it. And I will simply repeat same exact step. This time I will select this face. I click Sketch. Again, I simply need to create a copy of this rectangle, but I won't draw it again. In reality, I click Project Geometry, select this line, this line, this line, this line, so that I have obtained these yellow projections without drawing them. I select Offset. This time the offset must be 0.2. So I select this rectangle inside and I type 0.2. Okay? So that I can finish the sketch. And I will extrude again only this small part, but again, I won't extrude it on this direction, while I will click 2, take care 2, and I click this face here, click OK, and now I have the brick that has also these three completely different thicknesses for vertical, horizontal, and cylindrical parts. Okay? Till here? Okay, let's say that is yes till here, so that I will show you how I've made those small holes. Oh no, even better. Now we have to draw those three empty circles in between. So let's see this. In here there are three empty cylinders. There are these. 1, 2, and 3. So again, these are very simple now to be made, because look here. I have a lot of stuff that is drawn, and what I will do is simply, look, I project this, and that, but I don't want to extrude them. I just want to use them as reference, as well as projecting this geometry here. Then I will select them all, and I will click that they are construction. Then I will draw other lines. One that will start from the midpoint of this shape that I have projected. Then I will make another line from this center of my projected circle till this center, and I will make another one like this, so that I find this perfect center. Another way that I could do, just to show you how many possibilities you have, is you can also project this circle here, and for example, to find this point, you can create these angled lines. There are diagonals, so that you find this precise intersection points. But again, this is a construction, so I select all these lines and I make them as geometric construction, this as well. And I don't have to find type, dimensions, and nothing. All these construction lines are snapped to my pre-existing edges. So what remains is only I have to make a circle here, and I will dimension of this is 6.51. 6.51. Perfect. And then make another. I can do offset as well, but it takes forever. So I make another circle, 4.8. Perfect. And then, or you copy. That would be more educational. So I select both. I click copy. base point from the center till here. Here, maybe again, let's say I'm not that good. I click it here. Oops, I've made the mistake. No problems. Select both. Click coincident. It's one by one. It's okay. So this is coincident here, coincident there, and this is, oops, wait a second, and then this is coincident here. It's already there. Okay. Finish the sketch, and I will extrude these, but I haven't typed any number. And you can also see that even if my construction lines are intersecting the shape, when I select the space in between continuous lines, everything works. I click again to this face, so I don't type the distance exactly, and they reach this part, this beautiful element. Okay? We have almost done, and then see the magic. I select this face, I make my last sketch, where I draw a rectangle. Then, into the rectangle, I give dimensions. And let me remember, let me see, these dimensions are 0.2, and this one is 0.6. Perfect. And now look, I click coincident. This must be coincident. I forgot to project this line here. And again, this line is useful only as construction. So now I will simply select the rectangle and make that this point is coincident. Here, no, you don't like it, so it's collinear. So this line is collinear with this. Sorry, by mistake, without wanting, I have snapped this to the circle. I'm so sorry here. No, sorry, my fault. Let's put the rectangle somewhere else here, exactly. And then I said 0.2, 0.6, and then this line is collinear with this, exactly. And then from here to here, the distance is we don't know this distance, and instead of calculating, it is written that center of the rectangle matches center of the circle. So I draw the center of the circle, and then let's see, I select the rectangle and I make coincident. Midpoint must stay there. So I don't know the distance, but geometrically this is correct. Then I finish by doing this. Look, I draw this line. and I make it construction. And I select this. I click mirror, mirror line, this one, click apply, boom, and I have this one. Then I draw another construction line, this one. It has to be construction, so I select it and I make it construction. I select both rectangles, make mirror, select mirror line, apply, and I get my two rectangles down there. I'm almost done. I create this, and also I create from now this additional construction lines, so that I select only these two rectangles, mirror, mirror line, this one, apply. Now I select all of them, mirror line, this one, apply, and I have created all these little rectangles. And you will see in a second why I'm making these rectangles as separate from the sketch. Let's say I finish the sketch, I extrude them. I have almost done. I select all these tiny rectangles. Forgot to make the circle as a construction, but it's okay. To this inner face. And I click OK. The piece is almost done. Technically, the only thing that remains is this extrusion in the middle, but I know that you don't want to see it because it is just an extrusion. It doesn't really change anything. Okay? But ready for this? Because this is how I will make the 2x4 bricks, and check how to make, starting from here, the piece that instead is this one. Let me know if you can see it. That is a 2x4 plate. Because once that I have made all these steps and all this effort in creating this kind of complex thing, really I have no willingness of doing everything from scratch. So see what I will do. I will save this and I will call it live 2x4 brick. Then I click File, Save As, and see the magic. I will save this file just with another name, so I create a copy, and I will call it live 2x4 plate this time. And what I will do in my 2x4 plate, if I check my plate, I can see that the plate has not these rectangles here. So I select these, right click, delete. And the plate is just shorter, and technically this height here is the only thing that changes, and I said there is a modular aspect of Lego. So into the brick, this was 9.6. Into the plate, this must become exactly 1/3, so it has to be 3.2. So the only thing that I will do to change this into the plate will be, I will go to the beginning. Remember, that is where I've made the big box. So I double click my original box and I see 9.6. I change this to 3.2. I click OK. And without losing anything, but because all my other, and now this is 3.2, but because all my other sketches were depending on geometries that were there, I have nothing to redo, and I can simply create a second piece starting from that one. Okay? Till here? And I will save it. Because if I remember, then I have made, let me see, no, then I have made, no, I've made the one that has the angle. Let me see if I can show you quickly the preview. I've made this one. Open with photos. Then I want to just show you how I made this. That is fantastic. You want to see? In 3 seconds, how to make this element here. I know that the answer is yes. So check this out. I close the plate. I open my brick. Check this. To make the plate, and let me delete this. To make the plate, I have just extruded the box. So in one click, I obtain another piece. To make the wedge, what I do is this. I remove this one because the wedge has not. And this I know for a simple reason, that is, I have Legos. Then I go here, I double click the sketch, and roughly delete everything except for one center circle. Accept. And if this doesn't work, just double click extrusion and click OK again. Then I go here. This I will change it later. This I will change it later. I go to my extrusions where there are 8 cylinders. So I go here. Sorry, I click the sketch. And again, I roughly delete. I mean, I could just change them to construction, but I want to be super rude, and I will just delete them, accept. And again, if it makes these errors, double click on the function, click OK. We have almost done. Because now I have not more those, I have also to change this sketch, and I will delete these circles and click OK, accept, and again, if this is red, double click, select these and these in here, double click, yes, and here, yes, to this face, click OK, perfect. But beautiful part is that in reality I have simply made something like this. That is, I remove for a second the shell, and what I do is I select this face, I make a sketch, and I use this picture. Oh, I've closed it. Exactly. I have this picture here where I can see that this is 15.8, then goes up 1.2 millimeters, and then it is 45 degrees angled. So, in Inventor, I make a sketch that goes from here. It goes 15.8 millimeters horizontal, then it goes up 1.2 millimeters, then it is this line is 135, so I press tab and I type 135, and it goes till here. Okay, then I draw up, 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 up like this, and I close this line. I click finish. I extrude this weird shape, but I extrude it to this opposite face, and I cut it, and from a 2x4 brick I'm making the wedge. Then look, I quickly repeat steps that I've done before, like I will make this shell, what I will do is, you can see that this shell now is 1 millimeter, but I have to be 1.2. So I select this sketch and I move this, or I just delete these, and I do it later on, so I can just finish the sketch, and I will do this later, but basically I don't start from scratch. Oops, I deleted too many things here. What I do is, now I make here a circle, just to show you one extremely important step only. So look, I just want to show you this step, that is 6.51, and another circle 4.8. This is just one interesting thing, and then we will stop it. If I extrude it, what is interesting about this wedge is that the angled face is angled. And if I use the option called 2, and I select this face, this thing will go like this. Okay? I want to show you just this small part because what is interesting is that when you use extrude, you can also use the option called to next. So whatever obstacle the extrusion finds, no matter if it is an angled face or not, the extrusion will stop. And in one click, you have created circular lower extrusion that stops both into flat and angled face. Okay? And then I will save this as a wedge. Live. So basically, from one original 2x4 brick, I have derived all other pieces. Okay? We have been a little bit too long, but I hope these will start, helping you in understanding how many interesting ways there are to use Inventor. Okay? So, first of all, send me messages, send me videos, then we will also make a better experiment with the Discord. I also wish you a wonderful Easter break. Make these start working at your final project, because then weeks will fly. Okay? Let me know. Yes, no, maybe. Tell me something, because in this moment, if everything is clear, I will... Bye, everyone. Exactly. I will close this live stream so that I will start my next class. Okay? You too. Thank you so much. Perfect. See you guys. Send me messages, and also if you are subscribing this channel, and if you click the little bell next to it, when I will upload videos that are to clarify doubts or answer questions, you will receive a notification so that you will see that I have uploaded new videos. For now, bye.